All right then, so let's get started. So welcome everyone to our third Hacktoberfest event, Introduction to Open Source and Python Web Apps with Openverse. Presenting our speaker, Madison Swain-Bowden. Her pronouns are she and her. She's a data engineer at Automatic. And I'm just going to go to the next slide. So Madison is a senior data engineer in Seattle, and she's an avid Python user. She currently works at Automatic on the Openverse team and has worked at UCLA, speedtest.net, and the Allen Institute for Cell Science, and the Broad Institute. Like, wow, this is really impressive. And yeah, so everyone, I'm really excited to listen to her speak today, and I will hand over the microphone to you, Madison.
Perfect. Thank you. Hopefully you can hear me, and I'm going to share my screen now, do some Zoom juggling. Okay. Can everyone see that okay? Hoping so.
Yep. Yeah.
Okay. And hopefully that's still on the presentation. So, hi everyone. Happy time zone appropriate greeting. My name is Madison Swain-Bowden. Thank you for the lovely introduction, Eliza. Today, I'm going to be giving an introduction to open source Python web APIs with Openverse. I erroneously said web apps. Web apps are something very different and much more complicated than web APIs. Web apps do use web APIs, though, frequently. And they're also one letter apart. So apologies for the confusion. We're going to be learning about APIs today. But it should still be a really interesting introduction. So our outline for today, I'm going to talk just a smidge about myself because I've had a great introduction so far already. I'm going to talk about what Openverse is. Openverse is the project that I work on. I'm also going to give then a brief overview of APIs in general. The assumption that I'm making here is that you might have a little bit of experience with Python, but might not have any experience with APIs. So some of this is going to be really foundational, but we'll keep building on that. And there's plenty of resources out there to continue that learning and that building. And then lastly, I'm going to be talking about Openverse and APIs and how we leverage APIs both from a consumption standpoint and from a production standpoint, as in we use APIs and then we also produce our own APIs. And then lastly, I'm going to talk about, since it's Hacktoberfest, I'm going to talk about how folks can contribute to Openverse. Okay, smidge about me. That's me. Talked about where I worked. I live in Seattle. This is with my wife and our 3 pets. I have one of them here with me this morning. She may make an appearance if she decides to get up off of my wrist. But that's a bit about me. The team that I work with at Automatic is a team of sponsored contributors for the Openverse project. So Openverse is an open source project, and my company, Automatic, sponsors 8 maintainers to work on that project and help facilitate it. These 8 maintainers are from 6 different countries and speak over 7 languages. And they're a really exciting bunch to work with. They're also a gender minority or a majority gender minority team, which is a really cool experience to have. So I'm going to start off with what is Openverse, and I'm going to pop out chat here too to make sure that I can see any questions that come up. So you may not have heard of Openverse, but Openverse is a search engine for openly licensed media. That's our tagline. I'm going to go through each of those bits one by one. You can visit Openverse at wp.org/Openverse. So let's piece this apart. It's a search engine, right? Many of us are familiar with search engines, right? Let's Google it, let's Bing it, let's Openverse it. It's a tool that you can use to search for something and receive results back based on that search. The openly licensed piece is probably the most complex part of this sentence. So when you create a piece of work, some creative endeavor, a photograph, audio clip, you can use a license, think like copyright, right? You can apply a license to that media to ensure that people who choose to use it or who you make available to use it in the manner that you want them to use it for. So just read a little blurb from Creative Commons, who pioneered a lot of these licenses. Our tools provide everyone from the individual creator to large companies and institutions with a simple, standardized way to grant legal permissions to their creative works, which can be copied, distributed, edited, remixed, and developed all within the limits of copyright law. So there's a bunch of different licenses out there. You can think software licenses, right? There's a whole slew of software licenses. But for content licenses, there are different ones for, say, you don't really care who uses this. Everyone has the right to use it. Everyone has access. Or you can say, this particular piece of media that I created, I don't want it used for commercial purposes. But if you're using it for nonprofit or personal stuff, you're free to use it however you like. Or another license is you're free to use this for whatever. I would just like attribution when you use this piece of media. And last, media, intentionally generic. So right now we have over 600 million images and over 1 million different audio records. And we have plans to expand into 3D models, video, and text. So right now, if you go to wordpress.org/openverse and type in a search for bird, let's say, you will get back a whole slew of bird images. You might get back bird calls in audio form. You might get back rock songs that someone made entitled Bird. You'll get a whole slew of different results. And again, hopefully, down the line, we'll maybe have 3D models of birds. We'll have videos of birds flying really weird, something like that. We're hoping to add more media types down the line. So that's just a background on Openverse. I give that up front so you have some context for some of the things that I referenced with regards to APIs. But let's jump into APIs. So what is an API? API stands for Application Programming Interface. And it's a way for computer programs to talk to one another. This differs from a user interface. So like when you're using a computer, right, if you're going on to pay your credit card bill or something, you're using a user interface in that context. The API is something that's different from that. It's specifically built for machines to talk to one another. There's a bunch of different kinds of APIs. You have web APIs, which is what we're going to talk about today. There's also operating system APIs, package library APIs. If you've used like pandas or some R libraries, those libraries that you're interacting with have APIs that you use to perform whatever functions that you're doing there. Hardware APIs, if any of you have done like Raspberry Pi experimentation, you'll know that some of the hardware interfaces have like application programming interfaces that you use in order to interact with the hardware. On the web API front, web APIs use different kinds of web requests to interact with the API. So most of the time, this happens in JSON, which is short for JavaScript object notation. It's sort of a language specification for handling these communications. Another language that this occurs in is XML, extensible markup language. That one's a lot less common these days. Most APIs, in fact, almost all of the APIs that I have worked with over the last few years have been JSON APIs. So that's what we're going to focus on today. But I just illuminate that there are some different forms that this can take for the web, and many, many different forms for that APIs can take beyond the web. So a good way to think about interacting with an API is like ordering a meal, right? You have a customer, a waiter, and a restaurant. A customer talks to the waiter and tells them what they want, and the waiter then takes down that order, communicates it, brings it over to the kitchen and says, table number whatever, ordered this. The kitchen does their work, they produce the food, and then the waiter delivers it back to the customer. This metaphor is kind of a good allegory for how APIs work, right? A user of the API is that customer who's ordering off of a menu. The API itself is that waiter, and the process the API performs to bring that order from the customer to the kitchen is the process that the API follows. And then the kitchen can be seen as like the server that's running the API, right? It creates the response and then sends it back using that API. By necessity, the API has to be machine interpretable. So what I mean by that is the APIs are a way for machines to communicate with each other. And so it has to be, the way that they communicate has to be in a regular format. So you can imagine in another scenario, right? You're building a robot to go shopping for you. And if you were trying to build this robot to go shopping at a thrift store, that might be a lot more complicated, right? Inventory is constantly changing. The layout of the store might change from weekend to weekend. Things are going to look totally different every time the robot goes to the store. So it's going to be really hard to say, robot, I want a salt and pepper shaker, and have the robot know where to go to find that and to get it and bring it back to you. On the other hand, a supermarket might be a lot more navigable for that robot, right? Everything is in a specific bin. Usually there's a directory for the supermarket of where things are and where the robot can find things. It's a very regular way to interact with the environment. And so we have to think about APIs in that sense too, right? It has to, by the nature of the work that we're doing, it has to be something that's really, regular, normalized. Everything in its place. So I'd mentioned JSON earlier. This is what JSON looks like. I've taken this response from an API, which we'll use in a little bit. It's programming-api.herokuapp.com/quote/random. And so you can see this looks a lot like a Python dictionary. And we have keys that are, strings, and values that in this case are strings, and it defines some structure of data. Here we have, an ID for whatever record this is. We have an author, and then we have the English text description for this particular entry. And as I mentioned, it does look a lot like Python, like Python primitives, things like dictionaries, lists, integers, floats, strings, null values, right? Many of those primitives in Python are have a allegory in JSON, but we can't just, because JSON is a JavaScript based notation, we can't just use it directly in Python. And so I've pointed out we have ways to convert JSON to the stuff that we know in Python. And the Python standard library comes with this JSON module, and we can get from JSON to Python with that JSON.loads function, stands for load string. And then we can get back to JSON from Python using JSON dumps, similarly dump string. And there's a couple things to point out here that are different, right? If you're familiar with Python, on the right, series is none, owned is capital T true. Everything else looks pretty similar. But in JSON on the left, because it's, again, JavaScript based, none shows up as null and owned shows up as lowercase t true. And so that's why we have to do that conversion into Python to convert those values. And typically when we receive this JSON from a server, when we're making a request, it's just one big string. And so we have to work to decode that string into the Python object on the right. Any questions so far? Feel free to drop them in chat, or there might be a Q&A. Oh, there is. Is it something, sorry, to jump back earlier to Openverse stuff, is it something like a common creative license? Yes, the licenses on Openverse are almost all Creative Commons licenses. We also have public domain entities, which aren't quite Creative Commons, but we have a lot of well-defined Creative Commons licenses on there too. Okay, So this is, we're almost done with the JSON introduction stuff. Again, this is a lot of information. There's a lot here. And so happy to answer any questions. It will hopefully make a little bit more sense too as we start, toying around with these APIs. When using a web API, particularly what's called a REST API, we have a number of different methods that we can use for issuing these API requests. By and large, the most common one is a GET request. So this is just retrieving information about a requested resource. So if I were to go back 2 slides, right, if you put this URL in your web browser and hit enter, that your browser is performing a GET request on that resource. So it's just asking the API, please give me the information you have on this specific thing, right? There's also POST requests. So POST is usually used for creating or updating a resource. So think like you're filling out a Google form, and when you hit submit, that issues a POST request to the server that says, here's all the form response, here's all the form data for this particular submission. It's usually the second most common. A lot of times when interacting with an API, if you are, creating or inserting data, that's the method that's used. Because you're changing data on the API end, a lot of times those APIs require some sort of authentication or account in order to perform POST actions. So just be advised, GETs usually, a lot of times, APIs vary, web APIs particularly vary from the different providers that host them. But many of them you can use for free, like the programming quotes one that we're going to use is totally free, but in order to perform any POST actions, you have to have an account. Third method is put. This is specifically to update a resource. I would say in general, this is not a very common method. It's worth mentioning just so you're aware that this is a thing, but GET and POST are easily 2 of the most important to know ones. Put is also considered idempotent, which just means that if you submit the same put request multiple times, it's not going to do the same thing multiple times. So for instance, if you say, Jerry at table 24 ordered a burger, and you say that 4 times, then the kitchen's only going to cook 1 burger there. They're not going to cook 4. And then lastly, delete. Delete's pretty straightforward. You just are asking the API to delete a specific resource. Whether we're aware of it, APIs are all over the place. So APIs power desktop applications. I use a Git client, personally, a Git user interface, and that user interface interacts with the Git API that's running locally on my computer, right? They're behind web applications, right? I used Google Slides to create this presentation, and there's tons of APIs interacting there, saving my data and advancing the slides as I hit the right arrow key. APIs are used for mobile applications. If you have a mobile app, like I'm on Android, any app that I am running interacts with an API that the Android OS has for performing actions like playing audio or reading a file, something like that. APIs can also connect devices to the internet, and they connect everyday things like automobiles, doorbells, dishwashers, wearable devices. When I tell my home device to turn on the lights, right, it's interacting with the API of the lights manufacturer to say, turn on this device. They are all over the place. Okay, let's get to some examples. So, and you can follow along with this if you'd like. All you have to do is go to programming-quotes-api.herokuapp.com. URL's also on the slides. What's nice about this API is that in addition to having a surface that we can interact with in Python, which we'll get to, it has the API definition in a really a visible format on that front page. And so we're going to do some Zoom juggling here as I work to oops. Okay, hopefully everyone can see that. Fingers crossed. So first thing we're going to do is try out the author's endpoint. So all of these different blocks that we see are different endpoints that are available for us in the API. Endpoint being like just a URL that you can visit, right? And so what's nice about this is if we were to take a look at the authors, we get all this information about the author's endpoint. What the example response is going to be like, what the HTTP response code will be. 200 is usually good. That's what we're looking for, is 200.
Madison,
yes.
Sorry, Trip.
No, go ahead.
Can we go back 5 seconds, but also make the font a little bit bigger?
Yes.
For everyone to read.
How is this?
I think that looks great. All right, sorry, okay. I just have to backtrack 5 seconds.
No, you're good. You're good. Yes. So here we are, programming quotes API. And yes, programming -quotes -api.herokuapp.com. And yeah, we get presented with this lovely layout here. And each of these blocks are different endpoints that we can visit. And so we can actually take this, and we'll do this with the next one. We can take this and just put it directly in our browser. But for instance, here, we're going to get a list of all the authors. You can see this is a GET request. There are some down here that are post requests, but we'll just issue this GET request and we can try it out here. This interface actually provides a command line string that we can run, which is really cool. And then the URL itself. And then it includes the response body, and we get this lovely JSON object that has all of these names. Now, I forgot one step. The way, one other thing that this particular API provides us with is a list of models. So I'm going to scroll all the way down to the bottom of the page, and there's a section called models. And for us, they have all of the models that this API uses here, but the important things that we want to look at are quote and author. So if we expand the quote model, this is a description of the JSON object that we're going to get back for quotes using this API. So we can see that we have an ID, which is a string. We have an author, which is a string of max length 50. This max length is something that the API is saying they're going to abide by, right? JSON doesn't have any string limits or any validation that comes as part of it, besides, if it's a string or a float or whatnot. But this could potentially, the author could potentially be way larger than 50. But this is just the API saying, we're not going to give you a response that's greater than 50 characters. And then this is the English description, or the English translation of the quote. And it's also a string. And we can see that its max length is 500 and its minimum length is 10. So again, that's just specifications that the API is sharing. Not all APIs do this, but it's very helpful when they do. And then we'll take a look at author too. Author is a little bit different. So this is a name string, max length 50. It's probably the same string that we're going to receive here, if I had to guess. This wiki URL is defined as a URI string, or a URL string. It's a specific type, but again, this is just the API saying this is what we're going to provide. Because it's JSON, and JSON is very pretty simple. That's not something that's defined in JSON, right? So that's just going to be a string when it comes back to us. We also have a list of quotes that are coming back, and you can see that's a list of the quote objects, which are just above. And then lastly, when we look at the author endpoint, we do also get a quote count, which is an int. Okay, so jumping back up to authors here, we have our results, and we'll see that indeed this is a object that has a bunch of quotes. All of the keys are authors, and that this is the author's endpoint. All of the keys are authors, and we have a bunch of author objects that are coming back here. And we have quote counts for each one. And so as I mentioned earlier, we can just take this URL directly and copy it into our web browser, and we get the exact same thing. So post requests, this is a GET request, right? Post requests work differently, and we're not able to do quite the same thing with that. Okay, next we're going to look at quote count. So that's a different endpoint that we have available. I'm going to hit try it out and then execute. And we can see this is our response body. Notice that it's not wrapped in those brackets, right? A lot of JSON responses that we're going to get are wrapped in those brackets, but technically just sending a number back is valid JSON. Yeah, just something to be aware of. Not all of it's going to be dictionaries when we get it back in Python. And again, you can take this URL and just paste it into your web browser and get the same thing. And then lastly, we'll try a random quote. And here we've executed it. And here is our response body. We have that ID, that author, and then that English translation of the quote. Any questions on this so far? Let me jump back to Q&A. Are all web APIs REST APIs? That is a great question. No, they're not. There's a different, so REST is a API protocol, which is just a definition for how APIs talk to one another. Most web APIs are REST APIs. There's a different protocol called SOAP that is, I think, decades old, and it's not used very often. I've been doing data engineering since 2018, and I have never touched a SOAP API. I can't even say that I understand how SOAP APIs work. So yes, there are, but I would not be concerned about learning them at this time. A lot of times those APIs, the SOAP APIs tend to be with like really old enterprise stuff. API methods should be followed strictly depending on the operations, or are they just standard practices? Also a great question. When you are running an API server, usually you have to use that method in order to interact with that endpoint. So, and that's because you can have, it's sort of not ideal to do, but you can have the same endpoint handle different methods, right? So you could have one endpoint for quotes random that's get, which will just get a random quote. And then you, or even if we just said like, here's a perfect example, right? We have a get for quotes, which returns a list of quotes. We have post for quotes, which creates a new quote. And then we have put, which replaces an existing quote with a new one. So those all use the same endpoint. The method that we use distinguishes what action is taken when that endpoint is hit. Hope that makes sense. Can I explain curl? Curl is it's a program that is installed on Linux by default, I think, but might be available on Windows through Windows Subsystem for Linux. And it's just a way to make web requests from the terminal. If we, we can, where is it? It's up here. So yeah, this is just like a command line. Curl is a command line program, and this would be the command that we would run in order to get this result in the terminal. And I will show that. I'll show that a little bit later too. We can jump back to that. These are great questions. Okay, I'm gonna try and blast through them. So Swagger, Swagger is just it's this user interface that we're seeing for APIs, right? So this person has defined models in a way that Swagger says that they should be defined, and because of that, Swagger, this this library can then build this user interface on top of it. So the code that they're using to build this doesn't include all of the definition for this website. They just say, here's what my models look like, here are my endpoints, and Swagger will then build this for us. Okay, I'm going to keep moving on. We'll try to get to more questions in a little bit. So next, let's try doing the same steps in Python. So I'm going to do yet more Zoom juggling. Give me just a moment. Okay, hopefully everyone can see that. I'm going to make this super large. So, oh, here's what I'm going to do. Sorry. Okay. Sorry. And we're going to do the whole desktop. Okay. Hopefully, everyone can see that. One of the organizers, please let me know if not, but I will continue. So what we're going to do is the same exact set of steps, but instead of performing those actions, using the Swagger UI that API provided, we're going to perform them in Python. So I have some instructions here for creating a virtual environment that has a REPL, which is a read, evaluate, print loop. My favorite one is IPython. Please feel free to follow those instructions if you would like, but here I have IPython. And so we're in a loop for evaluating, Python code. We're going to import requests. I have on step C, pip installing that. If you don't already have that, requests it is a very common library in Python for performing web requests and interacting with APIs. And so you may have used requests before, or you may have interacted with a package that uses requests. A lot of different libraries use requests. And I have to spell it right. And then lastly, I'm going to set this URL because we're going to use this a bunch. So this is the base URL for the API that we're interacting with. Okay. And so then we're going to do the same actions that we had done in the UI using Python now. So response, we're going to try first that author's URL. That's not yet. And then I'm just doing some string interpolation to get that URL in. And then it was the /author's endpoint. So we're going to get that. And then to turn it into JSON, right, we just do response. Requests gives us this method for doing that JSON loads step. It's just .json. And there we go. We have the same values that we saw there in the web UI using Python. And so this, like I had mentioned, just returns a dictionary. Oops, there we go. And so we can interact with this like we would a Python dictionary. So for instance, I'm going to do add a Lovelace and see that she has 4 quotes that are in the system. We will try similarly the quotes /count URL. And then we'll do the same step, response.json. And there it is, 501. And that's the number of quotes that are in the system. Now, I do want to point out that that does come back as an integer once we do the response.json, right? If we look at, we can look at just the text that we receive from this response. And that comes back as a string. So just important to note, those responses that we're receiving as JSON are all going to come back as a string. And I can show that to you even further with the quotes random endpoint. We'll do the same step, response.json. And there we go. We have our quote, we have our author, and we have the English translation of it. We can take a look. Oops. We can take a look at just the English translation. We can do our normal, Python stuff. We can see how long is this quote, that sort of thing. We have this object back now. If we just take a look at the text that was returned here, you can see this is all just one string that encodes this JSON object. Sorry, the command I entered before the 6 responses, import requests, and then URL equals that URL. This is cool. So requests is like a Python alternative to curl. Yes, yeah, that's one great way to think about it. Is requests is like a way to do the same things that you would do with curl in Python. And you'll notice too on each of these requests, on each of these requests that I'm making, I'm performing .get. Requests also has like a hard to type and talk .post. Requests also has like these other methods that we can use. So this is like sending a post request to a URL. Okay, so that's our API introduction. I have 15 minutes left to talk about consuming and producing APIs. And then I'm happy to be around after too for questions beyond the hour. So we've consumed a little bit of APIs ourselves today as part of this talk. The Openverse catalog also consumes APIs itself. This is a really complex diagram. There's a lot going on. Ignore most of it. The important bit is on the left. So the way that Openverse builds this search engine is we have to have the data that backs that search engine. And we acquire that data by using APIs from different providers that offer openly licensed media. So you can see on the left, there's, I'm actually going to, sorry. Oop.
Madison, could you make the slider text a bit bigger?
Working on it, yes.
Thank you so much.
Okay, there we go. You can see on the left, we have Flickr is a huge provider of ours. We have the WordPress photo directory. We have a service called StockSnap. All of those are services that have APIs that we then go and pull data from and convert it into data in our database. So we have a bunch of different unique scripts for interacting with each API that pull the data from that API, convert it into the format that we use, and then store it in our database. And this is what one of those provider scripts looks like. This is on the Openverse catalog repo. It's the Cleveland data ingester. So this is for the Cleveland Art Museum. And you can see the endpoint on line 16 right there. That's like the top level endpoint that we use. We have a lot of machinery in the catalog for managing requests and for like retrying something if something were to go wrong. So there's not a lot of the like nitty gritty in some of these code examples that I'm going to show, but the general concepts are still there. One thing I didn't mention previously is that some APIs on top of endpoints, they'll also let you specify query parameters on those endpoints. So you can think of this as like, your endpoints are maybe your menu items, and then your query parameters are changes that you're making to that menu item. So you can say, I want, /hamburger, but /hamburger extra item cheese, right? And you'll get a cheeseburger back. So on lines 20 to 28, you can see we are adding some query parameters, which say, we only want, when we hit this endpoint, we only want X number of results. We only want 20 results back. And then when we keep doing that, we want to offset by 20 so that we get the next 20, that sort of thing. And here, again, because we just get this back in Python, it just becomes a dictionary. So this is just an example of us munging some of the data that we get back from the API into a format that we use. So on top of consuming APIs, Openverse also produces an API. So we, and that's under the Openverse API repo. So when you make a search, here's another very complicated diagram that you can ignore most of. When you make a search in your web browser, that search goes to a server that we have, which then forwards that search onto our API. That API makes the search request, gathers the results together, and sends it back to the web browser as JSON. And then your web browser has some instructions for how to interpret that and display all of those results. And so the big piece to pay attention to is smack dab in the center, that Django API. And so this is an endpoint that you can hit for Openverse. We have api.openverse.engineering/v1/images ? That's the query parameter, q equals code. And here's just one of the example responses that you'll get back if you go in your web browser to hit that URL. And you can see in this one we have the title of the work, we have the license, we have who we got it from, we have the tags, we have the upstream URL, and all of that's as part of the response that we're serving from our database for that query. So you can try it out. We don't have Swagger, but we do have a different specification which shows you all of the different types and the query parameters and different examples that you can use. I will say Openverse has our API is open, but we do rate limit requests if you don't have an a authorized account. But it's really easy to set up an authorized account. It's just a couple of extra steps. But yeah, feel free to try that out, api.openverse.engineering. And that has a list of all of our endpoints, our image ones and our audio ones as well. Okay, lastly, contributing. So it is Hacktoberfest, right? So I'm just going to give a small blurb on how to potentially contribute to Openverse if that's something that you might be interested in. There's a ton of different ways to contribute. We have a blog that's hosted on make.wordpress.org/openverse. And you can see, all the posts that we make. We typically share, decisions or questions or hey, we're thinking about doing this. What thoughts do people have on that? You are welcome to participate in any of that discussion. We also have a Slack channel in the Make WordPress Slack. And so you can get there at make.wp.org/chat. And in that Slack channel, every Tuesday, we have at 1500 UTC, we have a weekly community meeting. And so that meeting occurs in Slack. It's all text-based. So it's not like a Zoom call or something that you need to join. And people can participate asynchronously as well, which is an advantage of that. We have a number of community contributors who can't make that time, but they'll come in after the fact and type some responses to the different posts that are made there. And that's where we share wins from the last week. We talk about what's upcoming work, and then we discuss, different decisions or things that are being blocked or, PRs that need review, that sort of thing. All of the code for Openverse is open source. So I touched on the catalog and the API. Both of those are at the URLs on the screen. And then we also have our front-end repo. That one's not in Python, that one's in JavaScript, but it's also open for contributions, right, and open source as well. And I have all with an asterisk because the infrastructure definitions that we have are not open source, but you can still run everything, all of the different pieces locally on your machine. We have a really in-depth contributing doc too on our main repo, which is just called Openverse. And that document has a lot of guidelines and code of conduct and different ways to contribute, different types of contributions, how to get set up. It should have everything that you would need as a new contributor for getting set up with this project. And I mentioned types of contributions, right? A lot of people think that contributing is just submitting a PR, and it is so far from that. That's a piece of it, right? But in the grand scheme, there's so much else that's going on with a project that can be contributed to. So, for instance, we have we do a lot of our design out in the open. So like redesigning our header was a recent project. That design can receive contributions. So if you have a touch or a knack for design or want to get into it, right, we're welcome to receiving those contributions. Translations, right? We work to translate Openverse into a myriad of languages. And if that's an effort that you can help with, that is a type of open source contribution to make. Identifying providers. So I talked about like Flickr and the WordPress photo directory, StockSnap. We have a number of different providers, but there are tons and tons more out there that serve Creative Commons licensed media. And so identifying a provider and saying, hey, this is an API that I found that could be added to Openverse. That's a huge benefit for us. Code contributions are a part of that, right? Being able to contribute the different code changes and whatnot, submitting PRs, that's a piece of that. Text improvements as well. Things like documentation improvements, copy improvements on text that's on our website. Those are crucial for us. Another piece is bug reproduction. Many of us don't use Windows, right, on the maintainer team. And so if there's something that's happening that's just on Windows, having someone with a Windows machine to reproduce that can be really helpful. And also triage too, right? If we get new issues, helping us out, prioritizing and whatnot. And then lastly, recruitment is another way to contribute to a project. Getting people interested and invested in it is a way to contribute back to that project. And then we have a list of good first issues. We try really hard on the Openverse team to maintain this list and curate this to make it so that we have tons of issues that folks who are either new to Python, new to contributing, or just new to the Openverse project itself can jump in and help out with different issues. And so that's at bit.ly/Openverse good first issues. And then I had talked about like the Cleveland Museum provider and whatnot. We have in the works this great provider API template. And so, and this is for adding new providers to the Openverse catalog. And so if you are interested in playing around with APIs, this is a great way to get started on that, because building a provider ingestion script is like figuring out how to consume an API and then spit it in the format that we use or we have our data in. And this template is super helpful. One of our team members who doesn't do work on Python very much was able to use this template and create a new provider script for us, which was really cool. And then lastly, contributors are a huge part of the Openverse project. And I don't say that lightly. We had a new provider added. iNaturalist is the provider. And this provider was added almost entirely from the work of a community contributor who was putting in her time to make this new provider for us. And because of that, we were able to get 15 million and counting new images into Openverse because of the work that she did. And so you can certainly make an impact in this project as a community contributor. And that's it. Thank you very much. Hope that you learned something about APIs. Hope that you learned something about Openverse. And I will be happy to answer some questions.
One from Sandra. So what would you recommend for securing an API if you haven't already answered?
A great question. A lot of APIs, I'm so sorry, cat's making an appearance.
Ooh.
So if you are hosting an API, there are a few different ways to secure it, meaning you could require that folks who use your API use an access token. And that is something that is passed along, not as part of, I didn't get too much into the protocol itself, but not as part of the message body, but part of the message wrapper, as you say, I'm trying to request this resource, and here is my access token for this resource. And that is one way that you can, provision a more secure API. And then if a request comes through and it doesn't have that, it doesn't have a valid access token, you just reject it and say, sorry, I can't help you. I need a valid access token. There's a more secure one on top of that than just the access token that is called OAuth,
Okay.
and Openverse uses OAuth, and that's like it's like a two-step thing. Like not only do you need to request an access token, but then you request a token which is like a second token using that, which is only valid for like a day or something.
Okay.
And so that's just to make it extra secure. But that's one way to do that.
That's a great answer, Madison. I just learned more just like from listening to this part, just like securing token, like the dictionary to translate all the different words. But you did great, like explaining each one during the call.
There's a lot. There's a
Yeah.
lot of
Yeah.
vocabulary. Yes.
Yeah. Enjoy your drink. And so another question we had was they're asking, can I deploy my API on Heroku for free?
Unfortunately, I don't think you can anymore.
Okay.
I think that Heroku has changed their plans so that they're no longer offering a free plan, but there are other providers that will let you host stuff for free. So Glitch is one. I've used Glitch in the past a number of times. I still have a Glitch app that runs actually, and that one lets you have one app running for free. And I think Python Anywhere is maybe another provider that might also let you run Python apps for free online. But I don't think Heroku will let you do that anymore.
Okay. I guess another question, like say, I'm still a Python. Well, let's imagine I'm a Python beginner. And like, I want to start doing fun projects using like APIs. Obviously, the first one is like finding an API, like, API source, let's say Openverse. But then like, what's the next step? Like, how do I, there's so many things like to learn to do. Like how do I like, make it more efficient for myself so I'm not overwhelmed?
That's a tough one. So what we were doing in the terminal with getting the requests and like seeing the different objects and whatnot, this is literally what I do for Openverse. When I am trying to add a new provider or make update. I recently a provider updated their API, and so I had to change our script in order to match their new API format. And it's literally just this. It's like playing around with the responses, seeing what the data objects that I get back are, seeing how we can like manipulate that and use it and whatnot. So I would highly encourage just like playing around. And I use IPython. I really like IPython because there is a Python. If you just like type Python, you'll get into a REPL. But I like IPython a little bit more because you have a whole lot more. You get syntax highlighting. You get a bunch of other stuff. So yeah, recommend just playing around the API and seeing what you can do. And there's tons of APIs out there. The programming quotes one is one that seemed appropriate for this talk, but in looking for a good API to use, I came across like a D&D 5th edition API. There's like a Star Wars API. There are weather APIs that you can use, right? Sort of relevant for us, Eliza, as it's smoky here. I'm sure there's like an API that we could interact with for
Air quality.
getting the air quality data,
Yeah.
right? All sorts of things. So yeah, my suggestion would be just like start tinkering, start toying around with stuff.
Do you recommend any resources for just like, I want to learn about like APIs and all these definitions?
I don't have any specific resources because there's just so much out there. Yeah. One thing that you can use is hopscotch.io. I think it's, I'll try to type it. This might not be right. Hopscotch.io. I think there's two P's. There might not be one. I don't know. One of those two. But that is like a user interface for doing web requests, doing API requests. So it's sort of like Swagger, but instead of being specific to one site, it's just like super general. And so that's another way, if you didn't want to be doing a lot of this stuff in Python, you just wanted to be interacting with APIs. It's another tool that you can use to just start playing with different APIs.
Could you also post a link for Swagger in the chat? Possible? Or I forget which slide page it was on. Okay, yeah, now I see. Sorry.
Yes. Yeah, Swagger's just a framework. But yeah, hold on. Yes, here we go. Swagger.io. There you go. Swagger. So yeah, it's just a framework.
Oh, another person asking, are you able to share your D&D and Star Wars
Oh,
links?
sure. Okay. Yes. Yes. Yeah. Give me just a second.
I know we were discussing before. It's like, I was like, you think they'd be interested? I'm like,
I
oh,
know.
what
I
did
know.
they
I was
be?
trying to find.
It's like,
Yeah.
that's awesome.
Uh, yes. There was one. There was one article, and of course, I'm not going to find it. But there was one simple example APIs or something had it. Oh, here we go. This is it. This blog had a number of different like example APIs that you could use, and that's where I came across. Oh, Pokemon API too. That one seemed fun. So.
I guess what other Q&A questions I have for you, Madison. These are like fun projects to start to work on, but like, if I say I want to do it, like start doing a mini project at work, my workplace, is it like, should I just start looking for APIs every day? Like say I work in the real estate, or like I work in finances, or it just
Yeah,
really depends.
I mean, it does depend, but many of the different tools and whatnot that you interact with probably have APIs and probably have things that you can interact with. So like GitHub, right? GitHub has an API too. And it's because there's a lot that you can do with GitHub. It's like a pretty complex API, but we use the GitHub API for like different project automation that we have with our work. Yeah, it's worth just like looking up if certain services. Google has an API, right? AWS, right? AWS has a web API too, and that's what a lot of the Python packages use is that web API behind the scenes. And so it's mostly like one way to approach that is like what task do I want to accomplish, and then using that to figure out what services you might be able to interact with to get the information to accomplish that task.
I guess another question, Madison, did we discuss like what you do in your company? Like maybe some people might know what Automatic or WordPress is.
Yeah. So some background on WordPress. WordPress is also an open source. Well, there's two kinds of WordPress, but WordPress is an open source blogging software. And so I learned when starting at Automatic that like over 40% of the internet runs on WordPress, which was a really cool and surprising statistic. But yeah, the primary focus is just web work, web stuff, websites, web shops,
Blogging, websites, yeah.
Yeah. And a lot more beyond blogs, right? But Openverse fits into that mosaic because, if you're looking to add content to your blog or your website or whatnot, Openverse is a great source of images that you can use for attribution, right?
Yeah,
So
Creative
technically,
Commons.
yeah. So like technically, if you just like copy an image on Google Images, you like could potentially see some legal action for like using that for financial purposes or whatnot.
Yeah, for profit.
Right? Exactly. Yeah. And so the advantage of Openverse is like, exactly what when you find an image, exactly what steps you need to take in order to give proper attribution and like be within the legal limits for using that content. And you'll notice on my slides too, all of the images that I used were from Openverse, and I had the attribution on that slide as well. So it's as easy as that. And Openverse provides like the text that you can copy for attribution. And so it just it makes it super easy to be able to find and give proper or attribute the work appropriately.
So Lisa's question was, they've been playing with APIs for Fitbit and Strava. That's like a great resource. But Fitbit and Strava, they both require tokens. And they figured out that with Strava, they can refresh the token through the API. But they can't figure out how to refresh token through the API with Fitbit. Do you maybe have any like insights on how it's possible something Strava allows, but maybe Fitbit doesn't?
Yeah, that's a good question. I have to be honest and say I haven't interacted with either of these APIs, so I can't give specific answers to these. But it's possible that Fitbit may only require a API key, and that's it. Like you don't need to refresh anything. You don't need to, use that to request another key. So we have a number of the providers that we use. Jamendo is an audio provider. They just give us a token, and it's a string of characters, and they're like, this is your identifier, and if you're submitting requests with this identifier, we're going to let them all pass through at your throttle rate. And so we don't have to do any extra work. There are some other providers which we're hoping to use in the future. We haven't set them up yet, but those require that refresh. And so what you have to do with those is, as you had mentioned, you have that base token, and then from that you get more tokens, and then those are the ones that you use to make API requests. And so it's really dependent. As much standardization there is around like JSON as a way to communicate and like the REST framework and whatnot, there's a lot of like, oh, everybody does it differently in terms of like authorization and whatnot, and there's efforts to standardize that, but hate to say it's really dependent on the API provider. On what they can do. Hopefully their docs describe that, but that's also a question that's up to the provider. So we try really hard to make the experience for beginners contributing to Openverse as like easy and smooth as possible. And to the extent for instance, one of the community contributors who provided the iNaturalist provider, she had no experience with Python, no experience with Docker, or very little experience with Python, no experience with Docker, no experience with Airflow, which is a core tool that we use. And so we helped her get up to speed on all of those things so that she could continue to make more and more impactful contributions.
That's great to know. Final question, like you're working data engineering. Any opinions on a data lake versus a data warehouse or data swamp? Let's go data lake and data swamp. That might be easier.
I love me a data swamp. No, I have no opinion. I really don't. It's so situation dependent, honestly, on what the data looks like and whatnot. And here, like we have a data warehouse. We're maybe moving to a data lake down the line. Hard to say. No strong opinions either way. Yeah. Whatever is the right tool for the right job in the right place.
Okay, that's great to hear. Thank you so much, Madison. Thank you for like answering all of our questions and like presenting to our community on this topic. It was really helpful, and I feel like I learned a lot more like with APIs and like also how this helps contribute to Hacktoberfest, like because it's all open source projects, and I know we covered like a number of topics. So yeah, thank you everyone. Say like good morning, good afternoon, good evening, wherever you are, and I hope we have a good rest of the day. Okay. Bye everyone.
Thank you. Bye.